So, hi, Gordon. I think no one is interested in microprofile, and everyone burns to know what was your first computer and how you started programming. So, what is your first Hello World?
Well, when I was young, I had a friend who had a ZX81 and David Carville, and as well as playing chess on it, we used to do little programs when we could get the memory pack to stay on the back without wobbling off. And then, like most of my friends, at that point in time, there was a huge home computer scene. So I used to go into the shops in town in Glasgow where I grew up and write the little kind of like Hello World loops in BASIC, and then, or maybe even a beep to annoy the shop workers, and set them around in a loop. And I couldn't, at that time, I couldn't quite afford my own computer, but I had a friend who had a BBC Micro. Mm-hmm. So we used to do stuff on that. And then after a while, I saved up for an Acorn Electron, which was a sort of cheaper BBC Micro, and it had a strange architecture where it fetched the memory in nibbles, little 4-bit sections instead of bytes, and it had some sort of constraints, so it couldn't run all the BBC Micro games. So I remember hacking it to use the screen memory, be able to run some of the great BBC Micro adventure games, and using a little text window down the bottom. And the rest of the screen was kind of flickering away as the adventure game used the screen memory as its RAM. But they were really happy days. Lots of my friends were into home computing, and we used to, in those days, we'd play games, but we also kind of tried writing little games and graphic stuff, and people were doing it at school as well. So, and in school, I had an RML 380Z, which was like a kind of a school computer. And I actually had a friend who had a Jupyter Ace that could do fourth. Oh, so we did a bit of fourth as well when I was growing up. So we had lots of different things going on.
I believe the firmware or the OS from Sun stations was written in fourth, right?
Yeah, interesting. It's a stack-based language, a bit like the virtual machine, the Java virtual machine. Mm-hmm. So it's kind of like, if you can think in reverse Polish notation, then you'll be very happy programming fourth.
Cool. Anyway, you are one of my best guests because you had exactly the same computer I had. But yeah, you had a ZX81 and I had the Amstrad one with a little bit more memory, but it was ZX based, yeah, and I also did some BASIC.
Yeah, they were great computers. Some people use them for businesses as well. And in those days, it was so heterogeneous. There was so many different computers, and there was a lot of people, trying to build computers. I knew somebody who was involved with, I think it was a Dragon 32, it was called, or a Dragon computer, which was a bit of a clone of another design. But they, in those days, there must have been about half a dozen or more kind of homegrown computer designs in the UK at the time.
The ZX81, was it with the rubber keys, right?
Didn't rubber come in with the Spectrum? I thought it was wasn't it kind of wiped clean? I can't really remember.
But the keys, they were like, prepared commands, right? So R was run.
Yeah.
Okay. So I know what you had. Okay, perfect. Yeah. And how old were you with your first ZX? Yeah. Or how young?
Oh, I'm guessing it must have been like 13, something like that.
Oh, cool. And why you like the computer? So if you look at the computer today, no one is excited anymore. Yeah. So why you did something with it with 13?
It was just really good fun, and it was a kind of a world you could control. And I had some friends that were into it. And there was this very funny dynamic in school where originally I was going to be a vet, so I was doing lots of sciences, and I was actually in the kind of bottom form class in school. If you wanted to do 3 in sciences, that's just how it worked. And then you ended up some of the physical education classes and things like that were a bit of a jungle. But we soon worked out that if you picked computing as an extra option, you could get out of running around a dark, wet field in Scotland, and also all the kind of other things that used to go on in our kind of physical education at school, and swap it for sitting playing Planetoid on the BBC Micro, which seemed like a much better option to me. So that was one of the motivations as well that got me into computing at school.
Yes, but
if a better option.
But if I had a choice between basement and Scotland, I would probably choose Scotland. Yeah.
Well, I was lucky.
Perfect. So now, you said something in the high school. You had RML computer or Jupyter?
There was in school they had these big machines that called research machines. I think it was Research Machine Limited.
Okay.
They were kind of like an 8-bit micro that I think it was a UK company, and they managed to sell them into schools before the BBC Micro program came in. When a lot of schools got funding to buy BBC Micros, this was the kind of computer that you had to learn programming on, and there was one in the class, so you had to kind of do a lot of designing on paper. And there was no computing teachers; it was like the maths teacher's hobby subject. Okay. And then you would take turns on this 8-bit RML 380Z, I think it was, to run your program. But it was good fun.
Still basic?
It got us going. Yes, I think it was, yeah.
Okay.
It was all basic in those days. I think the first time I used something else was in uni. They were very Pascal orientated.
Okay.
That's what they used to teach computing because it was so structured. And then later on a bit of Modular 2, I think it was.
Okay. And what was your first reasonable program beyond Hello World, where you can say, okay, I did something interesting?
I did a graphics thing that did fractals. Cool. Like Mandelbrot stuff in different colors, which I was I quite liked that. It seemed to you could write a very sort of small. The great thing about the BBC Micro basic above most of the other basics is you could do recursion. So it was great for doing things like Mandelbrot programs, and you could produce sort of quite detailed images in not that many lines of code.
Cool. And after Pascal, what was the next machine?
Oh, gosh. So in university, they had some Commodore PETs with the big 8-inch floppy disks. We used to kind of, they weren't that reliable or fast, but they kind of worked. And then I remember we had one of the very first Apple Macs. And everybody used to queue up to do that because you could write your report on it and actually put pictures inside your documents, which was like a big wow factor then. So we actually had our own kind of bureau system going where we would, I think our final year projects were almost like camping out 24 hours to use this sort of one Apple Mac for doing our documentation and printing on. And they had central Unix type servers shared systems on them, and they were very interesting because I remember the sysadmin used to be a great bloke. He said somebody once asked him, what is it okay for us to do? And he said, you can do anything you want to because anything that you've got permission to do is okay. He was that confident. But we still discovered we could see other people's work on the printer queue. Everything, the Unix file system, everything was done using files. So we used to be able to spy on other people's work as they were printing it out. So he wasn't completely 100% tight on his security, but basically it was I think it was called Linux. It was a kind of a parallel Unix system. You could run things in parallel, and there was a C++ library, I think, that you could do some parallel tasks in. I remember correctly, Linux, I think it was. But happy days.
Yeah, cool. And Java? What is your first contact with Java?
Well, I got into Java sort of through transactions. Here in Hursley, we do a lot of transactions work, and that included, originally, before Java, I did some C++ CORBA transactions work. And
CTS?
Sorry?
CTS, CTS, CORBA transaction service.
Yeah, that's right. And SOM, the object model, and things like that. So we did a lot of work in that. And then when the Java transaction service started up, I think Hursley wrote the first sort of reference implementation for that. My first trip to America was as the kind of lead developer of the Java transaction service. And this is even before the Java Transaction API existed, before they kind of worked out how to get users to control it. Going over to what was then called JavaSoft in what I called Silicon Valley, to kind of transfer the technology for the Java Transaction Service to Sun, or JavaSoft as it was then. And then because I owned that and IBM had a kind of duty of service, I moved from the transactions group here in Hursley to the JVM implementation group. And I think at that point they might have been in think it was 1.2.
Okay.
And then I started working on there was a portability layer called the host portability layer that did all the sort of mutexes and threads and memory and mallocs and things like that. And I owned that, and that was implementing those on all the different platforms that IBM JVM ran on. I did that for a while. And then after that, I owned the classloader, the IBM JVM classloader. So I did a lot of stuff to do with the internal implementations of class structures, which was great fun, but it was a slight pain because I always remember if there was any heap corruption, it would be my code that would throw the exception. So I got quite a few calls to look into what was going on with heap corruption and things like that. But mostly it ran really fine. The JVM was a massive. We had massive test systems, and customers used to really hammer it in all sorts of innovative ways. So mostly it was pretty reliable, and that was good fun doing the class loading in the JVM. And I got really into Java then.
Okay, so you're also aware of CTG, right? The Common Transaction Gateway, probably.
A little bit, yeah. I mean, I tend to sort of specialize a lot because it was such a big team of people.
Okay.
And some of that happened after I was in the class loader, and then I kind of left that group quite a few years ago and went off to do. I think I did some Eclipse plugin programming to do with some prototype tooling work, and it was partly because
now the question. Do you enjoy, the Eclipse plugin model?
I loved it. Because
really? Really?
Yeah. Well. Yeah, because as a programmer, I used Eclipse all the time, and I think my ideal job would just be to write edit macros. If I could be paid to just write edit macros or Eclipse plugins for programming, working on my own tools, that would be close to my ideal IT job. So building stuff in Eclipse, I really love doing, and seeing when you do transactions, a lot of it, and also when you do like class loading, a lot of it is like looking through logs and working out what's right and what's wrong. Or we used to spend quite a lot of time making something a few percent faster. You might spend 3 months making some benchmark, 3% faster, and then a month later, Intel would bring out a chip which did even more than that with no code changes at all. Mm-hmm. And I loved that the Eclipse work because you could build stuff and then see it on the screen, and also we were interacting with users and showing them stuff, and they were saying, I'd like this a little bit this way or that way, and we could go away and change it and then come back and see, was it like this? So it was kind of a lighter experience. So I really loved it. Even though a lot of the code in Eclipse was very long-winded.
Exactly.
So there was a lot of boilerplate. But it was such a kind of low. The program I was running in such a low stress environment compared to the JVM class loader that I didn't mind the extra lines of code. It was so much fun doing GUI stuff. But it was lots and lots and lots of boilerplate, as you say.
Mm-hmm. So after university, you immediately joined IBM?
After a couple of interrails, I did. Yes.
Yeah.
I thought I was going to go back to university, and then the research funding for the group I was joining fell through, and then I suddenly thought, oh gosh, I've got to get a job, and looked around, and IBM were still hiring. This is in the autumn, and so I came to IBM. I think that's 30 years ago now, so that's quite a long time. But I've moved around quite a bit inside.
Okay. So, and JavaSoft, as you started, there was probably JDK 1.0, right? 1.0.
Yes, I guess it must have been.
Yeah. This is also where I got the Java. And by the way, the javasoft.com page, it still works. So you get redirected twice, I think. So, yeah. So this is also my start with Java. This was the first contact with Java. With JavaSoft. And regarding transactions, so how what I remember is, in Java, we had the JTA, the Java Transaction API, which was based on the JTS, which was the Java Transaction Service, and which used behind the scene the OTS, Object Transaction Service, which was based on CORBA, so you can have distributed transactions. This is how it worked back then, and even now, right?
Yeah, and the JTS was very, very close to the CORBA Transaction Service, which of course was very close to the XA spec, the XA spec. Mm-hmm. And you see this coming back. It's still coming back even today. The talk of, we're looking at, reactive streams, and people are talking about, well, how do we deal with transaction context? And flowing transaction context, into thread context. If we want to be kind of lighter on the threads and more portable across threads, how do we move transaction context around? And sometimes these problems, they seem to keep going on. Transactions is the gift. It keeps on giving. Someone once said to me, learn databases because everyone has a database, And,
exactly. My impression is like, I think it was around 2006 where MySQL was really popular. So there was a trend, we don't need transactions. So we can just store everything in MySQL, and transactions, we don't need them. And Java is not, or J2E back then, is actually not needed because transactions are complex, hard to understand, so we don't need them. And this, of course, you need transactions because it is really hard to make something consistent without a concept of unit of work. So something has to be done at once.
Yeah.
And if you find it out, you will suddenly find out, actually transactions are interesting productivity feature. And then everything comes back and gets even exaggerated. So you don't even get transactions. So the next question is, what about distributed transaction XA and so forth? So
yes,
So what I would say, if you really like to implement a distributed system, so take a look at transactions, take a look at databases. So and the relation between memory and persistent storage, and then you are golden. Yeah. Then you can use transactions or not. But this is like. We go going back and forth, transaction, yes, no, and this is actually really funny. So if we just record, all the blog posts from 2006 and reply them right now, it would be, you are still in, you can just reuse most of the articles even.
Yeah, I think you're right on the button, Adam. It's not, everything I say is from a personal perspective, but I always take an element of fashion recently. Someone once said to me that the IT infrastructure sort of became complete about a decade ago, and everything since then is just fashion.
Yes.
And kind of reframing things. And I remember SQL Server as well. One of the things I did was to take the JDBC driver for SQL Server, and they had the means of taking a transaction context on and off of a thread. And I wrote an XA JDBC driver that used the kind of Java Transaction Service APIs to find out what the XA transaction was. And it had a map between the SQL Server transaction and the XA transaction. And you could just map from one to the other, and it made it work. And those concepts are still around. Even yesterday, I was looking at, microprofile and the concept of event sourcing, where a lot of users, they're sort of saying, well, if I don't have global transactions, how can I maintain state? And, if I don't have XA distributed commit,
wait a second.
How can I maintain?
This is going to be too interesting. So, what I'm just the last piece is missing for your introduction. So you started with the class loader with IBM. What were fast paced to now? So you did the class loader, and after the class loader, you got the Eclipse plugin tasks, and then what you did?
Yeah. Well, then I went to the storage group, the RAID, distributed storage and RAID development in Hursley. Mm-hmm. And I did that partly because I'd been down in the JVM group. I was down in the kind of host portability layer and looking at kind of all the POSIX semantics and the mutexes and things like that. And there's a group here we've got a building, and a whole floor of the building is just full of machines with lots of sort of fiber channel cables coming out the back, and they build these fantastic storage controllers out of it's not commodity hardware, it's still enterprise grade hardware, but it's enterprise grade PCs, and they're all clustered in a kind of a clustered system which talks based on what's the algorithm again? Anyway, it's based on a sort of clustering system, all in Linux, and it does all this kind of event processing, and it's really kind of like techie. And there's a lot of people in Hursley because all the machines are in Hursley. So it was quite a good fun group to join. And I got into RAID and the algorithms of RAID and how those all work together. Mm-hmm. And I did a bit of that for a few years. And then I looked at the skills that I had it was a very interesting world, but there's not that many people in the world doing, RAID and clustered software using the kind of, that was using a kind of low-level C-type interfaces. And I looked around in the local area, and there was an awful lot of enterprise Java work. So I thought, well, the next thing I'll do, I think I'll go back to enterprise Java and do that. And that brought me to WebSphere and Liberty.
Okay.
And that's where I am now.
And when was it you moved to Liberty?
I think it's about 3 years ago.
Hey, cool.
Something like that.
By the way, Liberty is really great. So yesterday I was in DevOps Poland conference, and I used Liberty half of the talk behind the scenes, and people were really delighted. Say, okay, they asked me now which dependencies are you using? Then none, but which super prompts none? So it's just Java 8, and why so fast? I was like, I had no idea. It was always the case. So it is like. So for 3 years you're doing Java 8 again, and you are enjoying the experience, the Java 8 experience?
Yeah, I am. I think it's Liberty. I think it was a great thing because I started off with this sort of traditional large WebSphere, which is absolutely rock solid, and it's great for what it does. But as a developer, the sort of edit, compile, test loop isn't quite. It's not always a fast, great, lovely experience to go around that loop if you have to do it more than a few times an hour. Whereas Liberty is just so fast.
Yeah.
You can just once you have everything set up, you can just hack on it, and it just sort of runs almost instantly. You only have to recompile the sort of little sub-project you're in, and because of the OSGI mechanism, it just all runs. So it's a bit of a dream from a server development point of view.
Yeah, to give the audience a number. So yesterday the session was 50 minutes long, and in one point I took a look how many deployments I had with Open Liberty, and I had 35. But the session was not over. I actually forgot to look at the end, but I'm pretty confident there was more than 50 deployments a session, a conference session, and deployments took, I would say, 2 seconds at most, and I used a tool I wrote. Is a very simple tool. It just copies the WAR, so there's no magic. There's a complete rebuild. Basically, the tool is called WAT.sh. So it just watches the sources and copies the WAR, starts Maven clean install, and then the result is copied to the Open Liberty server. And the memory consumption is also very low. So actually, Open Liberty is one of the smallest servers I know so far. And so this is amazing actually. And the old WebSphere, I would say, was also great. So you could have more coffee. There's always time to get a coffee. with the Open Liberty is a little bit annoying because you have to work all the time. So there are no excuses. So there's no time for breaks.
Yeah, it's good. And sometimes there's a thing that's, I know you're absolutely on the button with how everything works, Adam, but there's also a thing for benefit people listening called a loose application, where if you're hacking in Eclipse, you can set up a little XML file in Liberty so it actually looks at the class files. So every time you press save and Eclipse does an automatic recompile of the class file, Liberty will automatically take that on board. So you can set it up without a kind of a WAR file, so that as you're editing, literally for me, I'm not so fast, but in the time it takes me to move my mouse pointer to the browser, it will have absorbed the change.
This is actually great tip. So what it means is, I also use NetBeans, for instance, and it saves and puts the class files first in an exploded format in Target. So I could set up Open Liberty to look into this folder, and on any change of the files, Open Liberty will reload the application, right?
Yes, that's right. And the thing to Google for is loose application in Liberty.
So send me a link. I will put it to the show notes, please.
Okay, sure.
Yeah, cool.
Certainly.
So and now back to transactions. So I just wanted to know to hear what was your road to Open Liberty. So I would just present my point of view, and then we can talk a little bit about transactions, because the next step would be microprofile reactive, and we can do more modern way. So we already covered JTA, JTS, and OTS. And so the first misconceptions of transactions is they are heavy. And this is absolutely not true, because if you have application server and you say requires new or transactional, it depends on the CDI, what happens then, in what I observe, is that the current thread is marked as transactional, and this is the overhead. So basically, you're setting the Boolean to true. You are transactional right now. If there are no transactional resources, nothing will happen. So there is no performance hit, right? So the application servers prepare, to pass the context somewhere, but there is no overhead. There is a very, very tiny overhead, but it's probably not measurable, right?
Yeah, I think that's typically true. There's sort of various optimizations. If I remember even in the CORBA days, if there was no resources got involved, you would try to do this kind of like last agent optimization to kind of pass on the transaction commit to other coordinators that would actually have resources. So,
but CORBA is distributed, right? But with JTA, we have just local transactions, so there is not even CORBA involved, I believe, right?
Yeah, that's true. But I'm just thinking that the application servers are quite sophisticated in what they do and trying to make things as quickly as work as quickly as possible. And I think transactions, if you need transactions, then I guess the ideal is that they are as heavyweight as they need to be and no heavier.
Yes.
So I haven't used a lot of transactions in terms of writing applications and things like that. Because although I work in the CDI, the squad that I work in now does do CDI, and we do deal with some transaction stuff in that. I am usually not down in the nitty-gritty of how the transactions work in WAS. Yeah.
Why I'm asking you this, because so I'm actually using transactions all the time, and I also advise clients and do some code reviews. And for me, simplicity is as important as performance, because if something gets too complicated, no one will understand that, and the application will have trouble. And what we do is just imagine we have like JAX RS service, which accepts requests from the outside. And the first thing that happens, we start transaction as early as possible, just by doing nothing. So if we have one EJB, it is automatically required. With CDI, you would put transactional on it. It's also required transaction level. And then the transaction, from the method is propagated to all methods, because the methods are called per reference. So we have like facade and then small services. This facade is called boundary, and the small services in control layer. And the cool story is, if you think from the business perspective, this is always right, because every JAX RS interaction is actually a use case and has to be transactional. And what I observe sometimes that developers start to optimize and try to deactivate the transactions on particular methods on the facade level, which can cause, of course, some trouble, because if they forget that and someone calls the methods, then we have half stuff is transactional, the other isn't. And my point is just, don't care about transactions. Let transactions be started on the facade level. If they are needed, they are needed. If they are not needed, there's no overhead. And funny enough, I measured the performance impact, and sometimes if you deactivate transaction, it's a little bit slower than if you do nothing. And I try, to investigate why this is the case. And the reason is, if you say never, the application server has to check there is no transaction. And if there is one, it has to throw exception. But if you do nothing, it will just stutter. So there is one if less, And so therefore, so from the business perspective, what I advise, don't care about transactions, just go with the defaults in Java EE. And then every facade is going to be transactional, and then everything is going to be consistent. So this is why I'm asking now about transactions. Right?
Yeah. I think that sounds sensible, and it also fits in with a good pattern of build something that works first, and then solve the performance problems. Once they arise. As long as you get your design sane, then quite often there's so much going on, and often it doesn't work in the way that people expect under the hood. I think if you try and double guess what the system's doing because you think it'll be faster, unless you have data,
exactly,
then you can often be wrong. I think the thing to do is to always measure and look for the data rather than kind of a human story about what's going on in modern systems, especially because there's been so many years now of optimizations and ways of doing things that often systems don't work in the kind of most obvious way that people imagine they do underneath.
And if you go with the model, like the facade starts a transaction, and let's imagine we get JPA, Java Persistence, just an idea, or we can do JMS or whatever but I think JPA is the most interesting part. What in larger application, what you can do, you can inject the entity manager, which represents, the storage, to whatever class you like. And if they take part at the same transaction, you will see the entity which was fetched, the first time as a reference to all other classes. And without transaction, you will get a copy. So this is the first added value, where it's not even the performance better. I mean, the performance is really better because you have one object and then multiple copies. But the really thing is, it cannot become inconsistent within the call, which is a big deal actually. And I was involved in contracts. We try resolve these errors, and the problem was always someone tried to optimize the transactions and deactivate them, and then we got 2 copies of the same object in a request.
Yes. And it can help you with locking as well. If you're in the same transaction, you don't have to worry about the transactional locking of the underlying resources as much.
Yeah. So transactions for me is like, they are interchangeable with thread of execution or request scoped. If you see CDI request scoped, every request is a transaction in a business context. If you're coming from from Jaxor's world, so it's like someone calls your service microservice from outside HTTP. So then every request is a transaction, right?
There's some interesting things on the horizon about trying to loosen up context from threads. With people talk about Loom coming and more reactive stream-based type processing. And there's sort of various models coming from people like Lightbend, more kind of actor-based, and some of the Spring transaction context going with the stream. I think it's still interesting. You'd think transactions might be over, but it's still interesting and still developing. And if anything, it's great to me that you're talking about transactions in terms of the making life simple, because I think a lot of what's happening for users at the moment is added complexity. We look at microservices and clusters being run and heterogeneous systems, maybe different languages, different consistency models. It's adding lots and lots of layers of consistency for the user. And when they have to manage their own consistency, it's just another complexity that they have to think about when really they just want to write their business logic.
Yeah. And so transactions. So we have now the entity manager, and what the entity manager does, I would say it is very similar what the database does as well. So basically, in a transaction, so correct me if I'm wrong, is you are working in memory as long as you say commit, and this is oversimplified, but at commit time, the memory gets flushed to persistent storage. So this is where the entity manager passes to a database, and the database memory passes the context to a file system, and on rollback the memory gets cleaned up, right? So it's just looking aside.
Well, I think if you're at the sort of application or middleware or maybe third-party libraries, there's a phase that happens even before the prepare phase, which is a kind of like a pre-prepare, which allows people who've got things in memory, whether it's like cache Java objects or writes that they haven't written to the database, to guarantee to be able to write them down into the resource managers before the kind of traditional two-phase commit happens. So that when, because the ordering of which actors get the prepares isn't really defined, it can guarantee that before the very first prepare goes to any resource manager, anyone that wants to register for that pre-prepare phase will have already written things they want the resource manager to work out whether it can commit or not.
Yeah, in two-phase commit. So what I understood is the prepare phase, it just flushes the state to a persistent storage or somewhere, and commit just releases the log, right?
But I think there's a third phase, which is before the prepare phase, which is a kind of a pre-prepare, which allows people to put all the data that might be in flight in memory into the resource managers that are going to take part in that two-phase commit.
Okay. And so I think transactions so far are covered. So the remaining statement is the misconceptions that two-phase commit is safe. So it is safe, but you have to catch XA exceptions, right? So you cannot just rely blindly that it will always work, because the resource managers can run to conditions like timeouts, and then the global transaction coordinator has to decide what to do. and sometimes it cannot decide. So you get funky errors like heuristic hazard, heuristic mix, or something like this, right?
Yes. I always remember when I worked on KixOS2, and we had these, very interesting error log messages about transactions being, kind of in doubt or timed out or whatever. And then we saw the Microsoft NT. I think they had a Microsoft NT transaction service,
MTS.
and they had on was that what it was called? And
Microsoft Transaction Service, right? MTS.
That's right. That's right. And they had this great GUI, and they had this kind of like a red ball for something that rolled back, a green ball for something that worked, and I think it was something like a sort of spinning orange ball just to the kind of left of the transaction ID in the log, saying, this transaction is kind of it needs to be kind of there needs to be some intervention because it's not gone one way or the other. And I just looked at it and I thought, that's so easy to use and understand compared to reading our error log messages. They have a green, just like a traffic light. It seems so sensible to me.
Yeah. So this is exactly right what you said. Is if you have two-phase commit or distributed transactions, you always will have to have human intervention, because if such a heuristic hazard or heuristic exception happens, someone with business knowledge has to decide what happens. And what usually, at least what you will have to do, is not to put the context, the error context, to a kind of dead letter queue and resolve it later. But and what I see in projects sometimes, and sometimes very often, is completely ignored. Try catch throwable, and if something happens, no one cares. So your system can really become inconsistent with that.
Yeah. The other thing I remember MTS added to the kind of world of the distributed transactions is they kind of solved the diamond problem. In XA and the OTS and JTS things, that there was always this issue of if a transaction arrived at a distributed node from two places, which one would sort of control the actual two-phase commit. And I remember the Microsoft Transaction Service solved that by having a kind of a global ID, and they did something in their .NET infrastructure because they had more to work with, that they could deal with recognizing a distributed transaction coming in from a second time from a different node as a kind of different subordinate coordinator.
Okay.
They hired some really good people. I remember there was some old school people who literally kind of wrote the book on transactions, and they hired some very good transactions people, and they wrote a good system. Yeah.
And the global transaction scope is not what we called XID and two-phase commit? Is something different?
But I thought you have this sort of distributed network. It's like a kind of a composite in the Gang of Four pattern terms. So you have subordinate coordinators which coordinate the resources and the actual coordinators that are acting as resources underneath them, and it sort of cascades out in a tree, and then it comes back in a tree. And these sort of like subordinate transactions, sometimes they can be implemented with something that might append onto the transaction ID. Okay. With the fact that coordinator knows that it's dealing with a global, its coordinator has a transaction ID, and it's allowed to kind of mess about with the transaction a bit. Okay. For the people that are registered with it.
Okay, got it. And okay, so now transactions are request response, so they will block until they are resolved. So we covered local transactions, distributed transactions a bit. Now the question is, now we do some reactive work. Now, why we can do better with something different with transactions, or what is the advantage, to do something different what you did so far?
I think there's two things. I think that people talk about reactive programming and reactive systems, and sometimes when you come into reactive from the outside, a lot of the material that you see is to do with back pressure and systems that perform, well at scale. And people might say, you have some sort of application and something happens, whether it's Black Friday or, something you get quoted on some Slashdot website or something, and you have this sudden large load comes into your system, and you have all these emergent behaviors which cause your system to basically act under a load that you couldn't really have system tested. And a lot of systems might struggle with that, with the scaling and so on. And what the reactive back pressure can give, if you have sort of end-to-end back pressure, is that the system, it still will be under strain, but at least it will be progressing as best it can. And a lot of people do talk about that as a benefit of reactive, but when I've been spending a bit more time with it, a bit like
just a short interruption, because the back pressure is really funny, because we had back pressure on application servers for years. Actually, everything was back pressured on application servers, right? Starting with all the pools, there was always a max size of pool. So we had the incoming thread pools, we had even the data sources and JDBC connections pools are nothing else than bulkheads and with back pressure. And
that's so true.
Yeah, and no one was interested in it. So actually, I remember 10 years ago, I gave performance talks at Java 1 about Lightfish. It was more than 10 years ago. So yeah, nice, but we don't need it. We go with Tomcat. And now and now they move on and do some Tomcat work or Jetty or whatever. And now back pressure is the thing, and I get constant questions. Do application servers support back pressure and circuit breaking and bulkheads? And I say, hey, this is nothing else we did, for 20 years. And now we have the term. Yeah, of course, they are supporting this. And I almost forgot about that because it was very natural. This is what we did for years. Like, we have an EJB with max pool size, and we can say what happens if this, the amount of parallel transaction is reached. So there was back pressure, and sometimes you got 503 or sometimes you got something else. But this was, the natural protection of application servers. And this is why actually this was a huge advantage of application servers over pure web containers back then.
Yeah. I could talk to you all day, Adam. It's great because you're exactly right. When did anyone ever say, oh, the big problem with my conversation between my DB2 client API and the server, or my SQL Server client and the server, is there just isn't good enough flow control? Nobody ever said that because it was not a problem. You were pulling data down in cursors, or when you wanted to use connections to put stuff onto the database, if you needed to, you had to queue to put stuff on. Mm-hmm. So this sort of reframing of a kind of in my experience, other people may have different experiences, of a non-problem as with a kind of nameable tag is not necessarily solving the real problems, that customers have. And there's great work in things like R2DBC. We can see, innovative stuff happen in terms of database drivers. But I don't think the customer value is in having better flow control to the database. It comes from other things. And I think for me,
I say one thing. Customer. So actually, the customers don't have such problems. Also, my customers usually there is a huge difference between conference talks and real world. So in real world, the applications are far more boring and less scalable than the consultants on various conferences actually would wish, and even what is widely underestimated, the raw performance on a single node server. So we are in projects in Java E. We had sustaining load of several thousand transactions per second on one node. So, and if you would start multiple nodes, then we got 20,000 transactions per second. And this is a lot for even a big business in Europe. So this is nothing for Netflix, but this is a lot, for an e-commerce shop or whatever you're doing right now. And I can just, I only have, a few projects with a massive big data. All other projects, they have performance requirements, but my clients are really extremely happy with the performance of application servers, and now it comes without any optimization. So we didn't optimize anything. So there was no JVM, no garbage collector, nothing. Just ship the simple stuff to production. And now consultants like me, I'm also a consultant. So we go to conferences and talk. Look, Netflix, Facebook, Google have these requirements, and now we need to do whatever, and come back, and everyone is confused. So I would say. This is the problem. Like, business don't have such problems in general. then the developers come back from conference and say, hey, look, now we have to be reactive. And I was in, akka-based reactive projects where developers asked me how to debug the system because everything was asynchronous. And at the end, the user interface was synchronous. And if you have a synchronous user interface and everything is asynchronous, this is really hell. This is like, this is
so true.
Mission impossible, actually, right? And they built specific tools, and I asked them why you are doing this, and they told me they were at conference and they wanted to scale. It's like, but even if all clients in your company would use your system at once, you wouldn't get these requirements. I mean, this is what we are doing here, and this is
it's so true.
Yeah, but
and I think there's the meme for that. The meme for that, or the phrase sometimes that's used here is "You are not Google." I think someone wrote a blog post or something, and it sort of touches on the meme that you're saying. You are not Google. But in terms of kind of thought leadership, I guess people who are at kind of internet scale type companies, they're seen as being the kind of technology leaders, and they're solving their problems. And I was chatting to somebody about it was in an Uber actually. It was at a conference, and I was chatting to someone else in the Uber, and we were talking about a reactive platform which is very sophisticated and does lots of fantastic things. And he was saying that in my shop we have a very mixed set of people, and we were trying to use this sort of very clever software, and the people that were enjoying it were the very clever people. And it was a kind of a human problem in a way, where they were trying to get stuff, out the door and working, and they maybe had too much sophistication for what they needed to do. And he said in the end, the kind of experiment that they did with Reactive got parked because they were, dealing with this extra complexity and more difficulty with debugging things, and they didn't necessarily see themselves as solving problems that they knew they were going to have with the application, and they went with more traditional techniques.
Yeah, so developer gets bored and then search for new shiny things. So this is like what happens in the world. But back to, let's say, I mean, this reactive thing is really interesting, but what we didn't explain what reactivity actually means. So in the classic definition, it's like you would have formula where like A plus B equals C, and if you change on B or A, the C would reevaluate itself. So you could apply reactive patterns even to data binding in user interfaces, right?
Yeah, that's so right. The original phrase, I mean, I think before it was used in the current context, there was kind of a reactive functional programming, which is exactly that. You've described there a small function, and there was this notion of functional reactive programming. But in our current context,
it's like observer, like this observer pattern with functions, right?
Yeah, it's exactly it's a pub sub system. Originally, it came from the .NET reactive extensions, where it was just the ability to subscribe to events on a topic, and it didn't even have back pressure originally. The concept of adding in the kind of like request and back pressure was added on after it was already the reactive extensions for .NET. So it was merely originally a pub subsystem where you could react to things happening, and then people ported that because of the push to have .NET across different languages. People ported that reactive extensions for .NET to Java, and then you got RX Java, and then the sort of system spread from there, I think. And I think when I look at what Reactive has given, a bit like the early Java days, it wasn't so much that Java could run on lots of platforms, because I had POSIX C compilers that could compile to lots of platforms. It was the kind of all the libraries that were shipped with Java that made it so powerful. And I think Reactive is a little bit like that, because for me, it's not the back pressure that makes it powerful. It's the fact that you can plug things together because of the power of Java generics and this sort of simple interface between a publisher and a subscriber. So you can get different technologies, and if they are, in quotes, reactive, there's a way of plumbing them together with a kind of small amount of Java. Where in the past, what you would have to do would have been to use that technology's APIs to pull everything out into local variables, and then use the next technology in your kind of application chain set of APIs to push things from your Java variables back into that technology. And Reactive does have the potential, when you get kind of comfortable with programming it in those sort of functional terms, to condense quite a bit of kind of Java glue code that's gluing these kind of different technologies together. For me, that's the promise of what Reactive can give.
I used or misused Reactive once, and it actually worked great. Is for input validation in UI. So it was like, you imagine username and password, and both of the text field has to be filled in. And if they are filled in, the OK button or login button has to be active. Otherwise, it is disabled and cannot be pushed. So, and this was actually you have two event sources, and with either they change the state, and if you change the state of either username or password, the button gets active. And this was very easy. So you could get rid of a mediator pattern, something in the middle, and just reactive, to have complex validations of user interfaces. And by the way, they were also very easy to test because you can replace the input fields with whatever you liked.
Yeah, that sounds good. I remember last year at Code 1, I wanted to do a little demo on what Reactive was. And it's kind of not really reactive, but I wrote a little thing that used some JavaScript to grey out a button. And then that spoke to the server, or the server spoke to it with some WebSockets, so that if there wasn't enough, request end tickets, it told the browser to grey out the button that would send more work in. Yeah. And it's not reactive in the kind of first 100 yards, as it were, or first 100 meters, but it was a visual representation of how load can be pushed back on all the way up to where it's originated in. We had a big example here in the UK of a bank that didn't test a new system under load properly, and even though they did stress test it, and when it went out to the customers, there was one part of the chain, I believe, that for messages, when it went above a certain capacity, it would start to spill over into storing things persistently on disk. And the problem was that people writing messages were writing them into memory. But it was the oldest messages that hadn't yet been processed that were kind of being spilled out onto disk. So people processing them, code processing the messages then had to read from disk. And as soon as it reached that tipping point, then, the system went off. At that point, the plane, like a huge star cruiser, kind of slowly tipping to one side and heading towards a planet, that the system went over the horizon and it didn't react well to the load. And then when people heard there was problems, there was more people used the system, and it basically was quite difficult for them to quickly recover.
Sounds similar to, I don't know whether you remember EGB passivation problem. So they were in memory, but on the load they could be passivated, which kicked in the serialization on disk, which was orders of magnitude slower, which slows down. And then you get, it never recovered from that. So But now, in our microprofile world, what Reactive basically means is you could consider WebSockets as a event source. Like list, for instance, it could be event source. You could consider WebSocket as a list of WebSocket events, and you can apply Java 8 stream and filter functions to it, right?
Yeah, I guess so. Yes, you can treat. I mean, when people sometimes ask me, how can I get into Reactive? I often say to them, and I should maybe follow this advice again myself, is to, learn about Java streams, underlying Java streams, learn about Java functional programming, learn about generics, learn about lambdas until all that stuff is in your toolbox and just, you can use it without thinking. And then the reactive concepts come easily.
Mm-hmm. And for request response or JAX-RS, it is, I would say, this is less interesting because it's request response, which is really, it shines as well like WebSockets, which is really hard to program, full duplex, request response. And what you could, of course, do is, to convert the HTTP JAX-RS request response into HTTP events, for instance. So you can put the event somewhere and treat them like a reactive stream. And what I always wanted myself, and you can probably answer this, the code behind the event source has to be actually pretty ugly, because what you will have to do is you will have to start a thread and block until something happens, and then receive the event and forward it to the event source, right?
I think you have it depends on what libraries you use. There is quite a lot of flexibility.
But if you implement, the library. So you are implementing the library microprofile. So you have to implement, the reactive messaging or reactive extensions with microprofile.
Yeah.
So you will have to implement that. So what it means is, if you have, for instance, HTTP, you will have, to wait until the request is over. So, and in a thread, for instance, you have to do something, and then read it and pass it to the event source, right?
Yeah. I think it gets very complicated. This echoes a conversation that was said recently where someone said, people trying to relate the microprofile fault tolerance spec and its support for asynchronous and using that in a reactive way. People were saying, well, this spec isn't reactive at all. And someone who was saying, but it can do asynchronous stuff. And they were saying, no, that's still going to block the thread. Just because it's happening not on your thread, it's still blocking, it's still synchronous, it's still not reactive, it's still an ugly fit. Mm-hmm. And I think a lot of in your brain, you're probably ahead of most people in terms of thinking in a systems way and how things will scale and how things work together, just because you've got so much experience of working with different users. But I think the boundaries between, when you've got something, for example, in JAX-RS, which even uses the word, reactive, when they're mostly talking about completable future and asynchronous type stuff, it kind of muddies the water even more in terms of what does it mean to be non-blocking? What does it mean to be reactive? And if you're trying to, I think there's some stuff in REST Easy that tries to implement reactive over JAX-RS, and they use server-sent events, I think, for doing.
This is part of JAX-RS, so you can use server-sent events, and there is an RX actually call.
Yes.
You use the if you do this, you get the standard Java 9 implementation, but you can also pass RX Java or whatever like. But
you can register. It has a map of handlers, so you can pass a class as a key and a handler, and then it will load your handler depending on what you've the RX one that takes a parameter. I think it is.
Mm-hmm. But in ideal reactive world, so what I will assume we get, let's say, I could inject event source, let's say HTTP event source and the database event source, and then use already database sync, and then use the event source with my Java 8 knowledge and map filter whatever, and then the result will be consumed by the database sync, and I'm basically done. This is actually the puristic reactive programming applied to microprofile, right?
I think that's where people want to head. I think when we have more reactive, when we have a kind of more reactive database set of classes, or there's some things in Spring, for example, where you can kind of plug things together, where the amount of code that is in the middle can be reduced. Mm-hmm. So that's where we're going, I think, with reactive. It's the ability to kind of plug things together without having to use local variables in the middle. And ultimately, a customer entity should be able to flow, all the way from an HTTP into a database store without very much customer code at all.
Yeah. And this could actually happen if we get environments like, I don't know whether you're aware of it, Knative or something like this, where we get cloud events, whatever happens is converted to an event first, regardless whether it's HTTP or message or whatever, then it would make sense. It, in my opinion, makes lesser sense if we have, still request response, sometimes servlet-based model, like JAX-RS doesn't have to be servlet, but is mostly a servlet. And then, if I already call the server and it blocks, and I have a method with parameter and return values, it's really hard, to be efficient or productive with reactive extensions in this world, right? Because there's already a break there between my request response and the reactive world.
I think it's a very interesting topic. If you connect two systems, say for example with Kafka, what you've got there is a massive buffer, and then what does back pressure mean there? You're doing if you've got a request going down some topic and then a sort of response is coming later on another one. What does it mean if you have back pressure there? Are you actually trying to disconnect sort of temporarily the performance of your front and back ends, or do you want them to kind of back pressure immediately, or is it just a sort of capacity level? I think these sorts of design questions it takes experience. I think I don't think we've kind of worked out in the large how to design for where to use reactive back pressure and where to use Kafka buffering, and it's almost kind of like a trending thing. You know, if the work rate coming in is trending so that it can be a problem, you know, what sort of smoothing function have you got in your queuing? It's almost like queuing theory, you know, and are you heading for some problem that you want to do something about because of some policy statement you've got in terms of the capacity of your buffer, or you know, the arrival rate is triggering something. It's quite a sophisticated set of thinking that I don't really see documented as a kind of theory. And as you say, many customers, real customers, don't have to worry about these systems. They build a system which is easily large enough and fast enough, and it will work.
Yeah, and Kafka is a trending topic right now. So I get questions about Kafka all the time. And what I hear a lot, which really reminds me the MySQL discussion 10 years ago. So like Kafka is easy, you know, way easier than JMS. Why we don't do Kafka? And what I see, like Hello World example from a conference where they just have, you know, single node Kafka and one topic, and it's really easy to consume. And my answer is always try to set up Kafka, you know, production-like, at least with 3 Zookeeper and all the stuff. And if you understand Zookeeper, and I don't know whether you saw, you know, the Kafka configuration, like 500 parameters. If you understand that, then you can do whatever you like. So then you can get rid of Kafka completely or implement your own Kafka. I mean, you know, this is and this is always like people expect, you know, like golden technology with zero knowledge send something back and forth in a distributed system, and this will never work. And this is this comes back and forth. Okay, cool.
And I think that's where the value. There's a lot of companies now that are sort of running Kafka as a concierge service. You know, IBM has event streams, which it will run on either public cloud or, you know, the IBM Cloud Private, and you know, Azure has one. Google's got a tie-in with Confluent. I think all the big tech companies are kind of running Kafka as a service because they're recognizing exactly that, what you're saying, Adam. Yeah,
but you still will have, you know, to configure the Kafka a little bit. And for instance, we use Kafka Kinesis on Amazon. And what was not clear that the messages only are retained for 2 weeks, for instance, right? So that you will still have to understand what happens behind the scenes.
Yes.
But now be more specific. So your work on microprofile, there's reactive messaging and reactive message operators, right? There are two things you are involved right now. Is it right?
Yeah. So, 3 just maybe. So the first thing we did was reactive streams operators, and that's basically a kind of reactive streams, you know, the kind of pub/sub interface implementation, plus some operators. And if you can imagine, a lot of that work was initiated by Lightbend and James Roper, and they were interested in bringing more reactive programming to the enterprise Java programmer. So they observed that the flow interface was in the JVM. But they didn't have there wasn't any useful operators. You know, flow's there so that it can be used in other specs. But without a useful set of operators like what's in what you get from Lightbend or RX Java or Reactor, then users aren't really going to use it. So they were thinking about, you know, is this a JET? Is it a microprofile spec? And reactive streams operators as a spec was born. And it wasn't primarily intended as a kind of business application interface, but it's more of a kind of enabling layer to do the plumbing, on top of which things like reactive messaging, which is basically a kind of message-driven beans type way of accessing reactive streams, for that to sit on top of reactive streams operators. And then just yesterday, there's some talk about perhaps having a work group to look at doing a bit more of event sourcing on top of reactive messaging in a way that Debezium does. I know you had Gunnar Morling on.
Yes.
So he's done some great work with Debezium that can sort of send change events around, and so it might be possible to do something a little bit like what they do, but based on top of microprofile reactive messaging.
Okay, so this event sourcing is like Debezium is like treating the SQL database as event source. So what they did, they implemented hooks to the database engines, and they can receive the events and convert them to Kafka events, for instance.
That's right. They do. They can do. For example, you could set up a cursor or suck out a table, and it will send the information across Kafka as change events. But for example, say you open up a cursor and it reads everything in that. It knows the timestamp. If you say have a repeatable read cursor, it knows the timestamp that set of data was taken. And it also has some great hooks into the database's log. And what it can do is it can look in that log, and from the timestamp that your cursor was taken, it can see what data might have been added after that cursor set was generated. And it can continue to add new data items that might appear into the stream of change events that it's sending to another system. So you could and all this can be done without changing the application or even stopping the application running. Mm-hmm. So you can suck out the contents of a database table that's live and also at the same time keep in sync with changes to that live database table and send them across Kafka using change events to be received by some other receiving technology, which can either put them into a database or you could write a Kafka connector that does what you like. Mm-hmm. And the concept of the microprofile event sourcing is to kind of do something similar to that, but a bit more at an application level. Mm-hmm. So if in reactive messaging, we've got the concept of connectors, which is initially you could imagine it as an abstraction over something like Kafka. Mm-hmm. But if we enable a system like Debezium to use a reactive messaging connector, it'll kind of make it more flexible in terms of what we use to send the change events around. I was reading interestingly recently about Lightbend have done some stuff to do with event sourcing where they actually use gRPC as a kind of distribution mechanism. So there's sort of various interesting things. And Kafka is a fantastic system, and they're kind of slowly expanding into lots of other things, such as, connectors and type schemas and things like that. And Debezium uses those, but sometimes I think some of our users, we might want to use Kafka for the distribution, but other things for perhaps doing the type conversion, whether that's microprofile config or other things. We want to kind of have flexibility and allow people to choose Kafka for what it's great at, but then not necessarily opt into the whole growing Kafka ecosystem.
Yeah, and Kafka is not the only thing. There are other great technologies, like, for instance, Apache Pulsar. I don't know whether you're aware of it. This is Kafka Next. And it is dangerous a little bit, to be completely dependent on Kafka right now, because I think we get the next fashionable technology in 2 to 3 years again. So, yeah. Yes. But going back to event sourcing with microprofile, so what I could do with that, for instance, I could implement my own event source implementation, which will, for instance, poll something and generate events, and then above the event sourcing interface, you could use, our own operator and consume the event and do some nicer work, right? Yes,
that's it. This is exactly the idea. But it does fit into your kind of like new and sparkly technology, because at the moment, what we're doing is just trying to kind of assemble a team of people that are interested in working on it. So it's completely open. If anyone's interested in working on change events in microprofile, then, have a look at the Google group, the Google microprofile group. And there's a repo over in under the small I implementation area, where we're looking for anyone who's interested in hacking on it or having ideas. You can raise issues or express interest in contributing.
Mm-hmm. Please send me the links. I will put it to show notes. Mm-hmm.
Okay, thank you.
And the is there any work going on directly with cloud events right now in microprofile?
No, it has been mentioned, and we for reactive messaging, we have a kind of message envelope where we take a generic type from a user and we wrap it in a message envelope, which is basically for handling acknowledgement. And we have got an issue to look at the nesting of these envelopes. So what happens if you want to get a user domain type, put it in a reactive message, but then maybe put that in a cloud event. You know, we haven't done that work yet to have kind of nested envelopes, but we are aware of it.
This is like what SOAP did, right?
Yeah. So, I mean, nothing's new.
No.
Nothing is new.
But the funny story with SOAP in the nesting was it was actually never used. So at the beginning of SOAP, everyone wanted to have SOAP because of the relaying. So you can pass the message along and enrich the message. And at the end, SOAP was misused as remote procedure call just for that, actually.
Yeah. Oh, interesting.
Okay.
Well,
cool.
I mean, it's...
Yeah, sorry. Go ahead.
No. Well, what you were saying was making me think of... I haven't yet researched it, but, you know, using messaging and then it ends up as a remote procedure call. And then I watched a Lightbend presentation yesterday where they were using gRPC. And I was thinking, oh, that's interesting. That's an interesting development. I need to go and look more into that.
Yeah. So perfect. So where people can find you on the internet and what's your Twitter handle and so forth, or if you have some interesting links, just... Yeah.
I got into Twitter in March this year, and my handle is GordHut, GORDHUT. And I've just started basically in the last, I guess that's 4 months now or something like that, been sort of tweeting and looking at Twitter. So you can find me there, or I think that links to a page that is a blog, but I'm not particularly active in that. But GordHut at Twitter, or you can find me hanging out in the Google group for MicroProfile.
Okay, cool.
Or on GitHub. If my GitHub ID is Hutchig, HUTCHIG, and if you raise an issue or tag me in any GitHub issue, I'll get notified in my Gmail, which will make my phone buzz. So that works as well.
What I would really like to do is to repeat the conversation more deeper with MicroProfile reactive extensions, transactions, or there are lots of interesting topics in MicroProfile in a couple of weeks. So we don't have, to reintroduce ourselves, so we can just focus just on the topic. So if you have time, it would be great.
Yeah, I would love that, Adam. I've really enjoyed it. It's great to speak to you. You've really got a good head.
Okay, thank you very much.